Saxon Algebra 2, Lesson 16. This is a two-parter. We're going to talk about multiplying polynomials, and then we're going to talk about dividing them. There are how many examples in all? There are 4 examples in all, 2 of each category. So that gives you a sense of where we're headed. Pure algebra, no geometry. Remember that the thing about multiplying polynomials, let me just show you an example. This is how John wrote the problem in the book. Copy, please. Every single one of these 5 terms has to be multiplied by all the others. It's a bit of a mess. When we just have 2 and 2, some people like to use this method called FOIL, and that works if you have, I'm just going to use letters instead of numbers, right? You multiply the first of each pair, you multiply the outside 2, you multiply the inside 2, and then you multiply the last 2, right? That gives you the instructions as which ones to multiply. I don't like FOIL. I mean, it works, it's fine. If that's what you learned, I'm cool with that. I personally don't like it because I have to remember what each of those letters mean, and it's more, it's not as visual as what I like to do. So I'm not a fan of FOIL, and I also don't like it because it breaks down when you have 3 parts, right? It works for 2 and 2, but it doesn't work for 2 times 3. See how there's 3 terms in this one? So, no thank you to FOIL. I'm going to show you a better way. If I were doing this problem as a student doing homework, I would not copy it out of the book like this. This is how I would copy it. I would start with the bigger of the 2 polynomials, 3x squared minus 5x plus 2. Then I would write the second one underneath it, justifying on the left, like so. This is called the vertical method. It's sometimes called the stacking method. I call it the dance, because in my imagination, we are in an old-time kids dance school. We've got a bunch of like 11-year-old kids on a Saturday morning. They're up in the 2nd story of some old store. This story is set in the 1930s. I don't know why. It's a big open room with windows along one side. The sun is streaming in, wooden floors. There's like mirrors and ballet bars because the dance teacher teaches ballet classes too. The sun is shining and the dust motes are kind of sparkling in the air. You know how that looks when there's a really bright sunlight in a big room and you can see the dust motes. There are 2 rows of chairs on the opposite ends. I have to draw the classroom. Here's where all the windows are. And there's mirrors along this side, and there's windows along this side. The teacher teaches them a dance step, and then all the girls are sitting in chairs on this side, and all the boys are sitting in chairs on this side. And in a carefully prearranged order, she has each girl stand up and dance with each of the boys. Then that girl sits down, and the next girl gets up, and she dances with each of the boys, one at a time, obviously. That is what people used to make their kids do on Saturday mornings. I don't think any of you probably do that or ever did that. I certainly didn't, but that's the image in my mind when I do multiplication of polynomials. These are the boys, this is the girl. For some reason, I always put the boys up here and the girls down here. It's just the way my brain works. The first girl stands up and she's gonna dance with each boy. By dance, I mean multiply. So 2x times 3x squared is 6x cubed, right? We multiply the coefficients and we add the exponents. That's an invisible 1. Okay, he's done. She sits down and dances with this boy. That becomes a minus 10x squared. Good job. Now she goes with the last boy, plus 4x. Beautiful. She's done. She sits back down. The second girl stands up, and now she's going to dance with each of the 3 boys. She dances with this guy. She gets 6x squared, right? Here's an x squared, so I'm going to put these 2 together. Here's where the metaphor breaks down. We just put the matching variables together. This becomes minus 10x, and then we get a +4 down here at the end. Now, everyone has danced with everyone else, and all that is left for us to do is to add 6x cubed minus 4x squared minus 6x plus 4. And let's make sure I got it right. Minus, minus, plus. Yay! That's the right answer. All right? So, this is, when I'm talking about multiplying polynomials, I call that the dance. And this is what I mean. The room, the dust motes, the kids getting up. The girls get to get up once and dance with all three boys. The boys have to keep standing up and sitting down. Boys on top, girls on the bottom. All right, let's do another one. Again, when John writes these in the book, he writes them in an unhelpful way. He writes them in a line. So I always like, I'm going to show you, but you don't have to write the wrong way first. I'm going to write the wrong way first. He writes it like this. Okay? Once I've written that, I realize that's not helpful. I need to stack it. I want to left justify it, which is a little weird. When we multiply regular numbers, we justify on the right? When you learned how to multiply in 3rd grade or whenever that was, we justified them over here. But with polynomials, we do it over here. What I'm going to do is just copy this much of it, right? And now it's in the order that I like. And I'll just ignore those parentheses. That's one way to get from John's way to my way without doing a ton of rewriting, which no one likes. I don't like to rewrite things. Okay, first girl does her dance. 3x cubed, then she goes to this boy, minus 2x squared minus 2x. Okay, she's done. This girl's turn. She becomes minus 6x squared plus 4x plus 4. And now we add 3x cubed minus 8x squared plus 2x plus 4. Let's see if I got that right. Yes. Multiplying by polynomials is something that we do a lot of. And so it's important that you feel comfortable doing this. And if you're not comfortable now, you will be soon, because we're going to do it a million times. The next part is dividing polynomials. No more dance. And no more something that we use all the time. Polynomials. This is kind of an obscure, dead-end topic. It's not something we're going to use in future calculations. It's just kind of a fun little magic trick that you can impress your friends with. I know you'll want to do that. 16.3. Next time there's a lull, in a sleepover or something, just go, hey, you want to see me divide some polynomials? And watch your friends fall into adoration. All right, I'm going to write it down the way John writes it down and tell you why it's completely unhelpful. Okay, divide, he says. I'll write it out. Divide okay, so he's telling us to take this big thing and divide it by that thing. Well, that's a fair request, and we can do that without much drama, but he has set it up all the wrong way. The first number, the one that goes inside the division box, and sometimes I have to do for myself, I have to do like divide 8 by 2. Whoops. Okay, that we go 8 inside the box and then 2 on the outside. Sometimes seeing it in words is confusing. So remember that this is what goes inside the division box and this goes on the outside. But this is in backwards order. We don't want it to look like that. We want it to go in order. 5x cubed minus 2x squared plus 5x plus 2. We want to fix the order of that. as a student doing homework, don't even write it down the wrong way. Just put it the right way right from the start, right? And then the same thing with this other part that goes on the outside. I want the x first and then the 4, okay? So we always place our expressions in descending, the order of descending power on the variables, right? Cubed, squared, plain x, number. That's the way we always want to arrange things in any kind of problem. All right, now, here's your reminder. When you do regular long division, again, like you learned in, I don't know, 4th grade or whatever it was, you learned there's 4 steps. The first step is to estimate. Oh, this is too crowded. I'm going to write it over here. No, I'm going to write it up here. 1, estimate. 2, multiply. Write these down. 3, subtract. And 4, bring down. I'll review what all this means. But these are the basic steps that you use in long division. There's nothing special about them for polynomials. We're going to use the very same steps when we divide by polynomials, so that's why I wrote them down and reminded you of them, is that the process is the same. It looks a little different, but the process is exactly the same. The way we estimate is we look at just the front part of the binomial that we're dividing by, and we look at the first term inside the box, and we say, what do we have to multiply this by to get that? All right? And it'll always work like this, where this will be smaller and this will be bigger. So we see, okay, in order to turn an x into a 5x cubed, we multiply it by 5x squared, right? That'll make a third x and we'll be good. That's the estimating part. Now we multiply, and in this case, excuse me, I had to yawn. Now what we do is we multiply 5x squared times x. Okay, well that's really easy because we just did that in our heads. But we also multiply it by the second part. And that becomes minus 20x squared. And notice that our x terms line up perfectly. We always check to make sure that's true, because next time we're going to get the wild card where it's not. Okay, so now we've multiplied. Now we subtract. Here it gets tricky. We put parentheses around the whole thing and we subtract like so. Now this one should always cancel beautifully. 5x cubed minus 5x cubed, it's gone. But this minus turns this minus into a plus. I change it and then I circle it to remind myself, you already changed that. Don't psych yourself out and try to change it again, because that's what happens if you don't circle it, is you see the plus sign there and you go, but did it used to be a minus sign and I changed it, or have I not changed it yet? Just circle it once you change it and then you're done. Okay, now I can add these two and I get 18, a second, I want my line of subtraction, 18x squared, right, minus 2 plus 20. And then I bring down my next term. Right? So we're using the same 4 steps. Subtraction is the hardest part of dividing by polynomials because you just have to be so careful about the signs. All right, now we start over again. What do we have to multiply by x to get 18x squared? Well, how about a positive 18x, right? Estimating. Now we multiply. Perfect. Now, 18 times 4. Let's work that one out. 2, 3, that's 72, right? So this becomes minus 72x, right? Okay. We subtract. This cancels, it's beautiful. This turns this positive. I circle it because I've changed it. 5 and 72 is 77x, and we bring down the plus 2. All right, next step, what do I have to multiply, or back at the beginning, what do I multiply by x to get 77x? 77. 77, now I multiply, and I get, sure enough, 77x. Now I have to do 77 times 4, so I'll do that down here. 8, 2, that's 28, it's 308. So this is minus 308. All right. I subtract this. This cancels beautifully. That turns to a plus. I circle it to show I changed it, and I get 310. There's nothing more to bring down. That's one sign that I'm done. Here's another sign that I'm done. What do I multiply by x to get 310? That's not going to work. There's nothing, right? Because there's no x in here, so there's nothing that's going to work. So now I'm ready to write my remainder. The way I do that is I take this number, and I write plus 310 over x minus 4. And this is my final answer. Let me double check and make sure it's right. 5x squared plus 18x plus 77 plus 310 over x minus 4. Yay, we got it right. Okay, so that's a quickie refresher on dividing by polynomials using those 4 steps. We have one more problem to do with the fun little wrinkle in it. This time, John tells us, and I'm going to write it out the way John does again so that you'll catch the trick when you see it. Divide minus 6 plus x cubed by minus 2 plus x. Okay, once again, we notice John has just scrambled these things up. He's made a mess of it. We know that this part, the first part, goes inside the box, and this part goes outside the box, right? That's the way it always is. But when we go to fix this, right, here's the box, we see, wait a minute, it goes from x cubed all the way down to minus 6. Where's the x squared and the plain x terms? They're not there. So what I do is I leave the gap, but what I do is I add those terms by putting a 0 in front of them, right? I'm filling in those place values, if you will, by setting the coefficients equal to 0. I don't have any of those, and that's exactly what I'm saying. I have no x squareds and I have no x's. But now I've created a space for me to add or subtract from those, and that is going to make a lot more sense when we do our problem. This I'm going to fix as well, right? I want them in the proper order. Estimate, multiply, subtract, and bring down. There, I abbreviated it. So here we go. What do we have to multiply by x to get x to the third? X squared. We multiply x cubed minus 2x. We subtract. Be sure to use the parentheses. That cancels. This goes positive. 2x squared, right? Because I'm adding it to my 0. 2x squared. And then I bring down plus 0x. What do I have to multiply by x to get 2x squared? Plus 2x. 2x squared minus 4x, right? This times that. I subtract. That cancels. This goes to a plus. 0 plus 4 is 4. And I bring down my minus 6. Cool, right? What do I multiply by 4 to get 4x? 4. I multiply. I subtract. That cancels. That goes to a plus. And I get 2. There's nothing more to bring down, so I know I'm done. It's positive 2, so I write 2 over x minus 2. If this was a negative number, then I would put a minus sign there, but it's positive, so I put a plus. Check to make sure it's right. X squared plus 2x plus 4 plus 2 over x minus 2. This is correct. Okay, so The extra takeaway I want to give you for this problem is that when you're writing this first number inside the box, make sure you have every degree of x terms available, right? Take whatever your highest one is that's given, make sure you have all of the smaller ones in place. If you're not given a value, like we weren't given a value for x squared or plain x, just add that into the sequence and put a 0 in front of it to reflect the fact that you don't have any of those. All right, set them all up ahead of time and then everything will go smoothly. Yay! Guess what? We're done. I will chat with you by video Thursday or Friday. Please check in with me. If you are not a student who normally video chats and checks in with me, if you have questions or problems or frustrations, you can always reach out to me. My email address is on my About page. So feel free to reach out to me if you have questions or if you want to see help with a certain problem or something like that. I am glad to help you out. Okay, I'm done. Thank you. Goodbye.